Today I'll talk about our work about subjective knowledge-based construction powered by crowdsourcing and knowledge base. So we know that knowledge base is very hot today, and it is a structured, computer processable description of the world. It has a lot of entities, and this have relations among them. And search engines powered by knowledge base can not only give you the website link using the traditional information retrieval method, but also can list you the direct answers to your query. However, the existing knowledge base only encodes the objective knowledge, which is observable and factual, such as the population of the city or the birthplace of a person. So it didn't capture the subjective properties. So if you search the objective queries, for example, movies by Christopher Nolan, it will give you the direct answers. But if you search the safe cities or cute animals, something like that, it will only provide you the website links. Here is more examples. European cities, it will give you a list of direct answers. But if you search beautiful European cities, it will just the website links. So what is the subject knowledge? In our mind, we define the subject knowledge focus on the set properties like big, dangerous, beautiful, cute, which is focused on human feelings and the qualities of the entities. And the true value relies on the people's domains opportunities. And each entities of a particular type can have a list of subjective properties. So here is an example, maybe this entities among a certain type for cities. We want to find whether this city is a hectic city or not. And so in our mind, the knowledge-based fact we follow the subjective predict and objective representations, and we want to enhance the properties, not only the objective properties, but also some SD pairs like we defined before, and the objective, not only the entity and the literal, and also some labels about it. So here comes our challenge. We know that knowledge base have already captured a lot of objective knowledge. So I think that this can be very useful, but how to use it? And the knowledge base has a lot of entities and relations. And if you manually label it, it will cost a lot. And how to resolve this conflict? So we propose the two-stage framework for subjective knowledge enhancement. The first step is the core subjective knowledge-based construction based on progress, and the second is subjective knowledge-based enrichment. We use the progress, which is a big graph of finding concept. It's not only have the it focuses on its relation, but the concept is not very general. Not only the very general concept like city, but it also captures some like big cities or popular films. So we extract the compound concept from it, and we also extract some positive or negative samples from it. However, the coverage of progress is not that good. For example, the cities, they have over 5,000 instances, but for big cities, it only have 500 of it. But DBpedia, another knowledge base, have a lot of rich entities and properties. So we can map the probase, the SD hairs from probase to the DBpedia tabs and extract the rich properties from it. And we want to enhance the entities not included in probase to get the labels of it. And we can observe that some objective properties will influence the subjective properties. So maybe if you want to decide whether a city is big, you probably consider the area or the populations. And also, you will consider the countries. Maybe 1 million, a city with 1 million populations in USA is a big city, but in China, we consider not. And in this stage, we focus on the property selections. We use this method, virtual information method to select the what objective property may influence that, and we further do the partial order relations on it. And here is the examples. For big cities, we may use the method to detect these two properties may related to the subjective information. And for this unknown city, we use this partial order. We can say that if the San Diego is a big city, then the New York is definitely yes. So this with this partial order relationship, we can form this the second state problem as a cross-layer instance annotation problem. And the instance whether can be annotated by the crowd or influenced by these rules. And we proved this problem as NP-hard, and we give adaptive instant annotation algorithm and prove its bound. But however, this with this human-in-the loop, it will cost a lot time, and we want to in every time we give a batch of it, and to minimize the time also. And here comes our experiment. We select 4 SD pairs using DBpedia, and select their properties. Here it is below. And we see that use the adaptive method, we can have the minimum cost, but the time is not the minimum. And it's quite, the time is quite a lot comparing to batch mode algorithm. And we also compare our method with some basic classification model, and it shows that we can outperform this other basic classification models. And here is our conclusion, that currently we didn't have the subjective information, and we use the objective information. We can learn some inference rules from it, and use the crowdsourcing. And this relationship, we can outperform some classical classification models with the same size labeled data. That's all. Thank you.